This is the lecture for lesson 20. This section covers quadratic functions, starting with characteristics of parabolas. We're going to determine the axis of symmetry, vertex, x and y-intercepts from a graph, and then we're going to determine the direction the parabola opens, its axis of symmetry, and vertex from both the general form and standard form. This is a general graph of a parabola. A parabola is a U-shaped graph, and it can either open up like it's shown here, or it can open down. Some key pieces of this graph are the vertex, which is either going to be the lowest or the highest point, especially if it's opening the other way. The vertex will then be the max. We have the axis of symmetry, which is the line that's going to cut your parabola in half. You have a y-intercept, and we have x-intercepts. Now, we can have 2 intercepts, 1 intercept, or we may not have any x-intercepts. So this is the only one that can be changing, 2, 1, or none. Given these graphs, can we find the vertex and the equation of the axis of symmetry? Well, the vertex of all of these is going to be a low point because they are all opening up. So in this one, here's my vertex here, and that is at -1, -1. Now, your axis of symmetry is going to be the line that cuts this parabola in half, and that is going through the x value of -1. It is a vertical line going through the x value of the vertex. Next one, our vertex is right here. That is at 1, 0. Our axis of symmetry is going to go right through that x value of 1, that vertical line, x equals 1. And then our third graph over here, here's our vertex. So if here's the origin, 1, 2, 3, 1 is my vertex. And then my axis of symmetry is the x value through the x line through the x value of the vertex, which is 3. So these will always correspond, the vertex and the axis of symmetry. Now that we can identify the vertex and axis of symmetry, we're going to go on and look at x-intercepts and y-intercepts. So x-intercepts, remember, there can be 1, 2, or none. And y-intercepts, there will be 1, always. So the x-intercepts are where they cross the x-axis or the horizontal axis. So those are here at -1, 0 and 1, 2, 3, 0. The y-intercept is where it crosses the y-axis, which is down here, 1, 2, 3, a y value of -3. So remembering that our x-intercepts are in the form x followed by 0, and our y-intercepts are in the form 0 followed by the y value. Looking at the next one here, here's my x-axis. My graph does not touch the x-axis, so there are none or no x-intercepts. But we do cross the y-axis. Now we need to be careful here because this looks like it's counting by 2s. 2, 4, 6, 8, 10. And this dot is right between that and the next line, 12. So that means we're crossing the axis at 11. So the y value is 11, means 0, 11. In this last one here, this is our first parabola that's opening downward. So looking at this, our x-intercepts are not marked, so I'm going to mark them quickly. We are crossing at -5, and we are crossing at 1. So -5, 0, and 1, 0. And our y-intercept is over here up at 5, so 0, 5. Here we have the general form of a parabola, which is going to look just like a polynomial. y equals ax squared plus bx plus c. A, b, and c can be any number except a cannot be equal to 0. Otherwise, we wouldn't have a parabola. From this equation, we can pick out the vertex by taking the opposite of b and dividing by 2a. And then we can find the y-coordinate of that by plugging that value back into the function. The axis of symmetry then is x equals that previous value from your vertex. Your y-intercept is 0, c. And then we can determine if the parabola is opening up if a is positive and down if a is negative. You will probably want to have this written in your notes so that you can refer back to it when you do homework problems as well as the quiz. So now we're going to determine the direction the graph opens, the axis of symmetry, and the vertex from the equation using what we just discussed on the previous slide. So the first thing we can do is determine which direction the graph opens, and that's by looking at the initial value right there. So A is -2, which means we are going to open down. If A is -2, B is 3, C is 9, we can now find the axis of symmetry. That is by taking the opposite of B over 2 times A. Well, B is 3, so the opposite of that is -3. And then we're going to do 2 times A, -2. That gives me -3 over -4. 2 negatives makes a positive, so 3/4. That is the axis of symmetry. It is also the x-coordinate of my vertex. So this is going to be 3/4, comma, and now I need to find out what that is. So I can do that by plugging back in. So -2 times 3/4 squared plus 3 times 3/4 plus 9. Now, if you have a graphing calculator or scientific calculator, you can type that whole thing in. I'm going to do some of the work out here, though. 3 squared, 9. 4 squared, 16. 3 times 3/4 is 9/4, and then plus 9. If I multiply inside here, -2 times 9 is -18 over 16 can reduce to -9/8 plus 9/4 plus 9. At this point, I'm going to use my scientific calculator. I'm going to add all of those together, and I'm going to get 81 over 8, which is my y-coordinate of my vertex. Now, sometimes you are going to get nice round values. Your vertex is 5, 2. There are other times that they may not be the most appeasing numbers. That is okay. All right, this next one, that should be a positive. We're going to do the same thing, but this is now our graph is 4x squared minus 8x plus 2. So A is 4, B is -8, C is 2. If A is +4, we are going to open up. The axis of symmetry is x equals the opposite of B over 2 times A. So B is -8. The opposite of -8 is +8. And then we're going to do 2 times A, or 2 times 4, which is 8. 8 over 8 is 1. So this one is actually a much nicer value to plug in here. So if we plug in 1, 4 times 1 squared, minus 8 times 1 plus 2 is going to give me 4 minus 8 plus 2, or -2. So my vertex is 1, -2. My axis of symmetry is x equals 1, and my graph is going to open up. Now, there is another form that parabolas can be written in, and this one generally is more called vertex form, but Newton Alta calls it their standard form. So the reason it's called vertex form is because you can pick your vertex out of it right from the equation. So what's happened is in like a factored form, y equals a times the quantity x minus h squared plus k. So the vertex, I'm literally just going to pull out h and k. So we need to know that if this is minus h, it comes out as h. If this was plus h, it's going to come out as negative h, whatever that is. The axis of symmetry is x equals that value. And still, the A is going to determine if it's opening up or down. So the equation we have now is going to be in vertex or standard form. And we're going to do the same things. Does it open up or down? What's the axis of symmetry? And give me the vertex. So looking at it, A is here. Here is H. Here is K. So A is 3. And if it's positive, we're going to open up. So inside here we have minus 2. So that means the axis of symmetry is positive 2. It's always the exact opposite of what it looks like in here. So it's minus 2, comes out as 2. If it's x plus 5, it's going to come out as negative 5. And then all I need to do is grab the k value, and there's my vertex. Clearly, this is a lot faster, a lot less work than the ones we just did. Next equation is the function negative 4 times the quantity x minus 1 squared plus 2. So in this case, A, H, K, A is negative 4, meaning that we are going to open down. In this case, H is 1, so the axis of symmetry is x equals 1. And then the y-coordinate of that vertex is 2, H, K. The last part of this section is going to be writing the equations. Given 2 points, given the intercepts on a graph, and given standard form, can we put it back in general form? The first types of problem, we are given a vertex and a point. So we want to get it into y equals a x minus h quantity squared plus k. Given our vertex in this first one is 2, 12, and 1, 9 is a point on the graph. The first thing we're going to do is plug in h and k. So y equals a x minus 2 quantity squared plus 12. Now we use the point to then solve for a. So we're going to let this one be the x and the y. So 9 equals a. 1 minus 2 squared plus 12. I'm going to do what's in the parentheses here. 1 minus 2 is negative 1, which I'm going to square is 1a. So 9 equals a plus 12. All I have to do to solve for a is subtract 12. A is negative 3. So now I'm going to go back and plug that in up here. So my equation is negative 3 x minus 2 squared plus 12. Okay, so the first thing we did was plug in h and k. Then we're going to plug in x and y so we can solve for a and then write our final answer. So we got 2 more here. In the next one, our vertex, so our h and our k, we've got negative 4 and negative 8. And then this is going to be my point xy, negative 2, negative 16. So following that process, y equals a, x minus negative 4 is going to turn into plus 4 squared, and then minus 8. Now I'm going to plug in y and x. Negative 16 equals a times negative 2 plus 4 squared minus 8. I'm going to do what's in the parentheses first. Negative 2 plus 4 is 2, which I need to square and subtract 8. So 2 squared is 4. 4 times a minus 8. I will add 8 to both sides. I have negative 8 equals 4a. So I need to divide by 4 to get what a equals, which is going to be negative 2. Now I'm going to plug that back in up at the top. Y equals -2, open parentheses, x plus 4 squared minus 8. And we've got one more following the exact same process. Our vertex in this one is 2, -11, so h and k, and our point is 4, 1. So there's x and y. So starting with y equals a, x minus h, so x minus 2, quantity squared, plus -11, or just minus 11. Now I'm going to plug in x and y. So 1 equals a times 4 minus 2 squared minus 11. 4 minus 2 is 2, which I'm going to square. So 1 equals 4a minus 11. I want to get a by itself, so I'm going to add 11 to both sides. 12 equals 4a. And to get a by itself, divide by 4 to get a equals 3. Plug that back in up top. Y equals 3 times x minus 2 quantity squared minus 11. These next ones are graphs, and what we have, our x-intercepts are given to us. So in this first one, x is -3 is an intercept, and x is 5 is an intercept. What I need to do is move them back into their factored form. So what that means is I'm just moving it back to the other side. So x plus 3 equals 0 is a factor. X plus 3. So this one, if I move it over, x minus 5 equals 0 is one of my factors, x minus 5. So the quick way is if you have a positive, you're going to write it as minus. If you have a negative, you're going to write it as a plus. Now, the last thing you may have to do is you may have to distribute this out here. And you would get x squared minus 2x minus 15. And you should see that that minus 15 is that y-intercept. And that is correct. Next graph has an x-intercept of -5 and an x-intercept of 1. So the factors are x plus 5 and x minus 1. Now the only difference with this one though is the graph is opening down. So because it's opening down, we need to put a negative in front of our factors. So x plus 5, x minus 1, and after I multiply this out, I'm going to change all of them to be negatives. So if I FOIL that out, I would get x squared minus plus 4x minus 5. But I need to distribute that negative in because it's opening down. So negative x squared minus 4x plus 5. And now you should see negative x squared shows me I'm opening down. And positive 5 is my y-intercept. So there's just one extra step when your graph is opening down. Last one here has an x-intercept equal to 2 and an x-intercept equal to 4. Which means my factors are x minus 2 and x minus 4. If I distribute those out, I'm going to get x squared minus 6x and plus 8, and I can verify that positive 8 is my y-intercept right there. The last one here, we want to turn it from general form into that vertex or standard form. Now, these are usually the most tricky to do. They involve a little more work and a process called completing a square. So we're going to start with this one here, and I'm going to explain how we do this. So we currently have f of x equals x squared minus 4x plus 6. What I want to do is I want to get my x piece to be a perfect square factor. So what I'm going to do is I'm going to put a blank here of something I'm going to add. I'm going to keep the plus 6. And if I add something to this side, I also have to subtract it because I have to keep this equation balanced. I can't just add something to one side of the equation because that would not keep it balanced. So the first thing I'm going to do is put in these blanks. So I'm going to put these first two x2 pieces, put a plus with a blank. I'm going to put the number by itself minus a blank. Now I find the blank by taking, this is A and this is B. So you are going to take B over 2 and we're going to square it. So negative 4 over 2 is negative 2. And if I square that, is going to give me 4. So I now have x squared minus 4x plus 4 plus 6 minus 4. So my equation is still a true statement because if I add 4 and then subtract 4, they cancel out and I'm back to where I started. But here's what I want to do. This has now created a perfect square trinomial. The two numbers that multiply to 4 and add to negative 4 are negative 2 and negative 2. So that turns into x minus 2 quantity squared. And then I can combine these two. 6 minus 4 is 2. And then I am done with my problem. Okay, so first step is you're going to make your blanks. Second step, you're going to take b over 2 and square it. That is what's going to then go into these two blanks. The next thing you're going to do is factor your perfect square trinomial and then simplify your result. Now, the easiest ones are clearly when it's just an x squared. Once I throw in a number in front of it, it's going to change the process just a little bit, make it a little extra step here. So if I work with 8, f of x equals 3x squared minus 2x minus 4. So what I need to do is I have to have it as an x squared. So what I'm going to do is I'm going to factor out the 3, making that x squared minus 2/3 x plus blank minus 4. And then I need to add, subtract. So I need to subtract whatever I add there. But it is 3 times that value. So 3 times the blank. Because 3 is outside of the blank, so I have to have a 3 outside of the blank here. I'm going to take b over 2 and square it. So b, 2 over 3, I've got to divide that by 2 and then square it. So 2/3 divided by 2 is 1/3. And 1/3 squared is 1/9. So 3x squared minus 2/3 x plus 1/9 minus 4 minus 3 times 1/9. So I just filled in the blanks. Now, this piece that you simplified here, b over 2, is the factored piece. So x minus 1/3 squared. And then on the end here, let's see, we have negative 4 and negative 1/3. So minus 4 and minus 1/3 is going to give me negative 13/3. So the trick at this point is once you figure out b over 2, the factored form is x, it's either plus or minus b over 2 quantity squared, and then plus whatever you get simplified on the other side here. So b over 2 was negative 4 over 2, which was negative 2. So x minus 2 was squared. When we did that here, it was negative 2/3 divided by 2 makes negative 1/3, which I square that. So that's why it's minus 1/3 here. Sorry, I forgot that negative. Okay, we have two more here. Starting with number 9, the function is negative 2x squared plus 8x minus 1. So I need to factor out that negative 2 from the x pieces. So x squared, that's going to make minus 4x. I'm going to put a plus blank. I've got my minus 1, and then I need to subtract negative 2 times that blank. Because negative 2 times the blank is going to give me the negative, and then plus 2 times the blank. So we take b over 2 and we square it. So b is negative 4 divided by 2 is negative 2, which we're going to square to give me 4. So I have negative 2, x squared minus 4x plus 4 minus 1 plus 2 times 4. And think again, negative 2 times 4 is going to cancel out with 2 times 4. And we're back to what we started with. So we're still good here. Okay, this piece is my factor x minus 2, quantity squared. There's a negative 2 out front. This is negative 1 plus 8, so that is plus 7. All right, number 10, negative x squared plus x plus 1. This always has to be a positive x, so I'm going to have to factor out a negative 1, making it x squared minus 1x plus fill in the blank, plus 1 minus, and then we got to do the opposite here. So negative 1 times the blank. So we're adding it here, we're subtracting it here. So b over 2 squared. Well, b is negative 1, so negative 1/2 that we're going to square is going to give me 1/4. So that's what I'm going to add in. Negative 1, x squared minus 1x plus 1/4 plus 1, that's going to be plus 1 times 1/4. So think about it here. Negative 1 times 1/4, there's your negative 4th. Positive 1 times 1/4, there's your positive 4th. They cancel out. I know I did it right. This is my factor here, b over 2. So x minus 1/2, quantity squared, plus, let's see, 1 1/4 is 5/4. So I know these may be a little tricky. If you get stuck, please just ask me. I can do some more examples, but that is the end of the section.